In this video, we're going to take tracing around the unit circle and consider the sine and cosine functions and look at how the graph that's created by doing such is similar to the idea of tracing or moving around the Ferris wheel. So first, let's remember that sine of theta is just equal to the y coordinate in the unit circle. So if we had some function f and we're inputting different thetas equals sine of thetas, then the outputs are just the y coordinates. So if I begin at 0, inputting 0 radians, the output is the y coordinate, which is 0. If I input pi over 2, the output would be this y coordinate, which is 1. Sine of pi over 2 is 1. Sine of pi would be 0. So we get 0. Sine of 3 pi over 2 is negative 1. So we get negative 1. And sine of 2 pi, remember 2 pi just means we went all the way around the unit circle. That would arrive us back at that same point where y is 0. So sine of 2 pi is 0. This is one period. One time tracing around the unit circle. And so notice how these points correspond to this graph. 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi is 0. If I trace those, that is one period of the sine function. So a few things to note if you're talking about sine. The period, the time it takes to get around the unit circle, is 2 pi units. The midline, if we look at our graph, notice how the midline is actually just the x-axis. Or if we wanted to state that as a horizontal line, it'd be y equals 0. And then the amplitude is the distance from the midline to a peak, or from the midline to the valley. Either way, the distance from the midline to the top of the graph is a distance of 1. Or from the midline to the bottom of the graph is a distance of 1, so the amplitude here is 1. We can do something very similar for cosine. Remember, cosine of an angle is just equal to the x-coordinate. So if I had a function where we're inputting angles in radians and we're outputting cosine of those angles, instead we're using the x-coordinates. For each of those check-in points, I'm looking for the x-coordinates. So cosine of 0 is actually 1. That is referring to this point right here. When we're at 0 radians, the x-coordinate's 1. At pi over 2, it's 0. At pi, the x-coordinate is negative 1. At 3 pi over 2, the x-coordinate 0. And at 2 pi, we'd return all the way around the circle. And so the x-coordinate there is 1. So we've got the points 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, and 2 pi 1. So here is one period of sine. Notice a couple just quick notes. Sine of x begins on the midline. Cosine begins at a peak and goes down to a valley. So that's a little bit different. So just in general, sine, well, let's say of theta, is going to have a shape like this. Cosine of theta is going to have a shape more like this. That's going to be important just later on if you want to try and recognize, are you considering a graph of sine or a graph of cosine? And I'm just referring to starting at the vertical intercept for those shapes. Much like sine of x, for cosine, the period is 2 pi. The midline is y equals 0. And the amplitude is 1. So what we do is we take the graph of sine of x and cosine of x, and we can transform them by putting values in certain positions. Let's start by talking about putting in a value of a. So here, this would be -3. Okay? Just to help us for some reference, I'm going to draw the midline on here. All right, so let's talk about what that -3 does. The first thing is, if that value is negative, it's going to cause a reflection. Remember previously, we said sine of theta would have a shape like this. Notice in our graph, instead of starting on the midline and going to a peak, it starts on the midline and goes to a valley. Then from the valley comes back to the peak. Here is one period of this graph. So that is a reflection over the midline. Instead of going to a peak, this graph goes to a valley first. So the negative in front causes that reflection. The next thing is that the absolute value of whatever that a is will be equal to the amplitude. So in our graph, we've got -3. The absolute value of -3 is 3. Notice how the distance from the midline down 1, 2, 3 units, or from the midline up 1, 2, 3 units, the amplitude is going to be 3. The next important value that I want to talk about here is this 5. Since it's +5, it has shifted the entire graph up 5 units. That number is equivalent to the midline. If it was negative, it would have shifted the graph down 5 units. So the midline here is y equals 5. The last value I want to talk about is this value of k. It dictates what the period of the graph actually is. The period will equal 2 pi divided by that number. So here, k is 4. The period is going to be 2 pi divided by 4. So 2 pi over 4, we can divide both those by 2. That'll actually reduce to pi over 2. So the period should be pi over 2. Notice that in our case, here is the period, which is pi over 2. All right, so let's just look at an example. Y equals 3 cosine of x. Well, first, I want to start by noting again, cosine in general will have this shape, beginning at the vertical axis. Notice how we have that shape. Okay, so what is the period of this graph? Remember, the period equals 2 pi over k. In our function, k equals 2. So the period will equal 2 pi over 2. 2 over 2 cancels. This is just going to have a period of pi units. Notice on my graph, the length of time to get that full rotation of starting at a peak and returning to it is pi units. Okay. The amplitude will be whatever this value of A is, particularly the absolute value of it. So the amplitude will equal the absolute value of 3, which is 3. In our graph, the distance from the midline to the peak is 3, or from the midline to the valley is 3 units. So the amplitude will be 3.